Hello everyone. Today we're taking a look at Unit 1, Lesson 7. We're going to continue our discussion with word problems, just kind of building off of what we did in the previous day's lesson and continuing to look at word problems in a certain format. Okay, so our first example is going to be another mixture type of word problem, and then we're going to do one more example of just a standard kind of distance, speed, time mixed in a little bit, but you'll see what I mean when we get there. So let's try this first one. So it says a metal alloy is 25% copper. Another metal alloy is 50% copper. How much of each should be used to make 500 grams of an alloy that is 45% copper? So we're taking a metal alloy that has that 25% copper and we're going to mix it together with a metal alloy that is 50% copper. So we should think that this is a mixture problem. And when we have those mixture problems, just like in the previous day, we're going to set up a table. Okay, so let's first identify our variables and then we'll set up our table. So let's let X represent the mass, and in this case our mass is in grams, of the 25% copper metal alloy. And we will let Y represent the mass of the 50% copper metal alloy. Okay, now we'll create that table. So let's write, our first column will be our total mass. So we know that we have, actually, a bit more there, total mass. We know how much our mass is going to be when we mix those two together. So we have to figure out how much of X basically and how much of Y we're going to need to make 500 grams. So our total mass is, we're going to have X, we're going to have Y, and then we're going to mix it to equal 500 grams. Okay, and then we have to take a look now at our percentages in terms of how they affect the mass. So we will say percentage of copper. Okay, so our X grams copper is going to be at 25%. Our Y metal alloy is going to have 50% copper in it. Okay, and the mixture that we're going to create has to be 45% copper. Okay, so then we're going to figure, okay, well then what is the mass of copper going to be that we're going to use of each of these metal alloys to make our mixture? So we can represent that by multiplying those terms together. So it's going to be 25% of X, so we represent that with 0.25X. It's going to be 50% of Y is going to be copper. And then as a total, right, within this mixture, we want it to be 45%. So again, 45%, and I'm just going to draw down here. It's going to be 45% of 500, so we can multiply those. And when we multiply 0.45 times 500, we should get 225. So now, just like we have in previous days' lessons, we're going to get one of our equations from this column, and we're going to get one of our equations from this column. So the total mass can be represented as an equation 1 of X plus Y equals 500. And then the mass of copper will be our equation 2. And we can represent that by, again, just adding the mass of copper that's in metal alloy X, the mass of copper that's in metal alloy Y, and we know that we're going to end up having 225 grams of copper in that mixture. So we're going to have 0.25X plus 0.50Y equals 225. Okay, so now we have to decide if we want to use substitution or elimination. You could for sure give elimination a try, but you are going to have to do some multiplication by decimals, which is not always ideal. So I would say for this one, substitution would be a better choice. So let's rearrange that equation 1 because that already has no coefficients on our x and y. It'll be the easiest to rearrange. So let's rearrange equation 1 for y. Doesn't really matter which one. So we have x plus y equals 500. I'm going to rearrange it so I can get y by itself. So we'll have 500 minus x. And then I'm going to communicate what I'm doing. So now that I've rearranged, this is my new equation 1 I've made here. We are going to sub equation 1 into equation 2, right? So this I just want to make a note here, we are going to do substitution as our method. Okay, so we're going to write our equation 2, but anywhere we see a y now, we're going to substitute in that 500 minus x. So we have our equation 2 is 0.25x plus 0.5, and then we usually have a y there, but instead of y, we're going to substitute in that 500 minus x, and that is going to equal 225. Okay, so now we have to simplify by expanding into our brackets. So we're still going to have 0.25x plus, and then we'll do 0.5 times 500, which is 250, and then 0.5 times a negative x is going to be 0.5x equals 225. We'll combine our like terms. So we have 0.25 minus 0.5, so you have a negative 0.25x plus that 250. And then we will continue to isolate for x, so we'll move the 250 over to the other side of the equation. The 225 minus 250 is going to be a negative 25. And then we will divide both sides by that 25, negative 0.25. And we should get that x is equal to 100. Okay, so we've gotten one of our variables, so now I'm just going to come over here with my work, and we are going to sub that x equals 100 into whichever equation is easiest, and to me, equation 1 looks quite easy. So we're going to put it into equation 1 because we just have x plus y equals 500. So instead of x, I'm going to plop in that 100 plus y equals 500. And then we are going to isolate for y. So y equals 400. So that's what we found our values to be. The last part we're going to need to do is we're going to need to check our solution in the other equation. Since we just used equation 1 in that last step, we are going to check our solution in equation 2. So we will do a left side, right side check. So the left side of our equation is 0.25x plus 0.5y, and the right side is 225. So we'll substitute those values in for x. So for x we have 100, and for y we have 400. So 0.25 times 100 will be 25, and 0.5 times 400 will be 200. So in fact that will equal 225. So left side equals your right side. So then we can just conclude with our therefore statement. So therefore, you will need okay, and then we'll take a look at our variables. So that x variable was 100, so 100 grams. And if we look back up at those let statements, 100 grams of 25% copper. And then our y variable, so and 400 grams. We look back at those let statements. The 400 grams is our y, which is our 50% copper. Okay. All right, let's take a look at one more word problem for today. Okay, let's take a look at this next question. So Fred took 10 hours to drive 1,000 kilometers from London to Montreal. For part of the trip, he drove at 110 kilometers per hour. For the rest of the trip, he drove at 85 kilometers per hour. How far did he drive at each speed? I just want to highlight this because we always got to make sure we come back to this question. So how far did he drive at each speed? So we've definitely been given information that we've seen before. So we should be thinking about our distance, speed, time formula. We have distance, speed, time. So see if we can come up with some equations that help us with this. So we know that for part of the time he drove 110 kilometers per hour, and for the rest of the time he drove 85 kilometers per hour. But we don't know, that's our unknown. We don't know what length of time he drove at those speeds. So let's let x represent the time spent driving, and actually let's say the time spent in hours driving 110 kilometers per hour. And then we'll let y represent the time spent, again in hours, driving 85 kilometers per hour. All right, this is a little bit different of a distance speed time question because it's not a straight distance equals speed time. They've given us some other information to work with. They've given us lots of information about time, right? We know that there's some X amount of time that they drive 110 kilometers per hour, and there's some Y amount of time that they drive 85 kilometers per hour, or Fred, I should say. And in total, Fred drove 10 hours per hour. So we can write an equation based on that, right? We know that time is going to be however many hours X is plus however many hours Y is equal to 10 hours in total. Then we were given some information about the distance, right? So we have our time here, and then if we're going to write our equation 2, we have some distance here to work with. Let's make sure this is our equation 1, and now we should be able to come up with a distance equation. So we know that X hours, he's driving 110 kilometers per hour. So if we're trying to figure out the distance, we want to do the speed times time for that distance, right? So that's going to be the speed is 110 times the time spent doing that is X, okay? Plus, we also know that for another part of the trip, he drove 85 kilometers per hour for Y hours. So again, we're going to do speed, which is 85, times our time, which is Y. And then those two speeds together are going to equal our total distance, which in this case is 1,000. Now, when I look at this, I really like the idea of doing substitution again, but we're going to do elimination on this one just to see the other strategy that we learned. So I'm going to multiply equation 1 by 110 so that I can get the magnitude on my x's the same. Okay, so this will become 110x plus 110y equals 1100. Okay, nothing to change about my equation 2. It'll be 110x plus 85y equals 1,000. That's my new equation 2, and that's my new equation 1. Okay, so now when I look at these, I've gotten the same magnitude on my x's. They are the same sign, which means we are going to subtract them from each other so that we can cancel out our x's. Okay, so I'll put a line, I'll put a subtraction. So 110x minus 110x, they cancel out, they're gone. 110y minus 85y, that'd be 25y. And then 1100 minus 1,000 is 100. So we'll just use algebra to continue isolating y. Divide by 25, and y is equal to 4. Okay, and then I'm going to sub y equals 4 into the easier of the two equations. So I'm going to sub into equation 1. So we have x plus y, which we've just found y to be 4, is equal to 10. So x equals 6. And then the last part of this is, of course, we've already substituted into equation 1, so now we need to check our solution in equation 2. So we will set up our left side and our right side. The left side of my equation was 110x plus 85y, and that right side of our equation was 1,000. So we found x to be 6 and y to be 4. So if we do 110 times 6, we should get 660 and then if we did 85 times 4, we should get 340. Okay, so if we add those together, we get 1,000. Okay, so the left side equals the right side. So we could go ahead and we could say, okay, x equals 6 hours and y equals 4 hours, but I come back to that question we started with that I said, remember, we're going to have to answer this question. So the question was, how far did he drive at each speed? And so we're going to need, I'm just going to draw an arrow up here. We need to find the distance driven at each of those speeds. And actually, we kind of just did that in our check, but I just want to make that point again. Okay, so for 110, right, 110 kilometers per hour, he drove X hours, and we just found X to be 6. So he drove 660 kilometers at that speed. And then when he was driving 85 kilometers per hour, he drove that far for Y hours. And we just found that Y was equal to 4. So if we multiply those, he drove 340 kilometers at that speed. So just to wrap up with our therefore statement, so therefore Fred drove 660 kilometers at 110 kilometers per hour and 340 kilometers at 85 kilometers per hour. Okay, so you have lots more word problems to practice with. Continue to practice so that you're comfortable setting them up and then working through that substitution or elimination method. That's it for today.